Using mathematics and computational thinking. Although there are differences in how mathematics and computational thinking are applied to science and in engineering, mathematics often brings these two fields together by enabling engineers to apply the mathematical form of scientific theories and by enabling scientists to use powerful information technologies designed by engineers. Both kinds of professionals can accomplish investigations and analysis and build complex models which might otherwise be out of the question. Students are expected to use mathematics to represent physical variables and their relationships and to make quantitative predictions. Other applications of mathematics in science and engineering include logic, geometry, and in the highest levels, calculus. Computers and digital tools can enhance the power of mathematics by automating calculations, approximating solutions to problems that cannot be calculated precisely, and analyzing large data sets available to identify meaningful patterns. Students are also expected to engage in computational thinking, which involves strategies for organizing and searching data, creating sequences of steps called algorithms, and using and developing new simulations of natural and design systems. Classroom instruction should enhance all of the science through the use of quality mathematical and computational thinking. Constructing explanations and designing solutions. The goal of science is to construct theories that give an explanation for how the world works. Students are expected to construct their own explanations as well as apply standard explanations they learn about from their teachers or reading. An explanation includes a claim that relates how a variable or variables relate to another variable or a set of variables. A claim is often made in response to a question, and in the process of answering the question, scientists often design investigations to generate data. The goal of engineering is to solve problems. Designing solutions to problems is a systematic process that involves defining the problem, then generating solutions, testing, and improving solutions. When students demonstrate their understanding of the results of a scientific idea by creating their own explanations of phenomenon, they are engaged in an essential part of the process when conceptual change can occur. Engaging in argument from evidence. Argumentation is a process for reaching agreements about explanations and design solutions. In science, reasoning and argument based on evidence are essential in identifying the best explanations for natural phenomena. In engineering, reasoning and arguments are needed to identify the best solution to a design problem. Argument in science goes beyond reaching agreements in explanations and design solutions. Whether investigating a phenomenon, testing a design, or constructing a model to provide a mechanism for an explanation, students are expected to use argumentation to listen to, compare, and evaluate competing ideas and methods based on their merits. Finally, obtaining, evaluating, and communicating information. Being able to read, interpret, and produce scientific and technical text is a fundamental practice of science and engineering, as is the ability to communicate clearly and persuasively. Scientists and engineers use multiple sources to obtain information used to evaluate the merit and validity of claims, methods, and designs. Communicating information, evidence, and ideas can be done in multiple ways using tables, diagrams, graphs, models, interactive displays, and equations, as well as orally and in writing and through extensive discussions. Teachers can help students by explicitly teaching how to read scientific texts by using applicable reading strategies. Teachers can also teach students how to read tables and graphs and expose them to scientific journals. Lastly, students need to communicate their learning through a science notebook, a display like a poster, or a presentation.